So the problem we're looking at is one where one has to determine whether a list has two elements that sum to a target value. So, um, for example, if we look at numList, right, we have a target of 12 and we have this numList. So if we walk through, we can easily see that 5 and 7 sum to 12, right? So we'd return true. However, if we didn't have a 7 here, if we had maybe 123, some random number, no number sums to 12, and we would return false. So that's the gist of it. It's a fairly straightforward problem. However, it becomes interesting in that there are three very different ways to solve this problem, each with improving time complexities. So let's start with the brute force solution, right? So the most straightforward thing to do is to simply take every possible combination of any two numbers and add them together, right? So we can start with negative 234, and then add that to 43, and then do negative 243 times 545, and so on and so on and so on. And the problem with that is you end up doing a lot of double counting, and it's just generally inefficient. But still, let's see what it looks like. So the first thing we do is we define the length, right? And then we're going to use the length to create a nested for loop. And this is to access every single element. Okay, so once we've done that, all we really have to do is access the values at their indexes. So we'll have value equals numList of I plus numList of j. Okay, so now if target is equal to value, we'll return true, and if it's not equal to target, we'll just keep walking through the list. So all you have to do is this. So if target equals value, return true. Now the only thing we have to be careful for is you want to make sure that we're not counting the same index twice, right? So for example, we don't want to add negative 234 to negative 234, right? So all we have to do is just add this little clause right here. I is not equal to j. Okay, now this is pretty much the problem. The only thing we have to do now is add a return false at the end. And that's it. It's the most straightforward, least elegant brute force solution. Okay, so for a little better implementation, what we're going to want to do is we're going to want to sort the list, our list of numbers. And in order to see what this will do, let's have a little example. So let's say we have a num list, it's equal to some random numbers, negative 10, right? And then we'll make up a target. Our target is equal to, I don't know, 30. And then let's sort our list. It's equal to negative 10, 34, 54, 234. Okay, so what we do is we're going to want to keep track of the minimum of the list and the maximum of the list. So we're going to want to start at the far left corner and the far right corner. And what we're going to do is we're going to add these two together. We're going to add negative 10 to 234. And then we're going to compare that to the target. Right, so in this case, negative 10 plus 234 is equal to, what is it equal to? 224. So 224 is much bigger than our target of 30. So we're going to want a smaller value. So we're going to leave our left index alone, negative 10, and we're going to change our right index because we want to move from a larger number to a smaller number. So we're going to move from 234 to 54. Okay. Then we'll add negative 10 to 54. We'll see that it's still greater than the target. So we'll move the right inward again. And then finally we end up with negative 10 and plus 34. And this is equal to 24, which is actually less than our target. So we'll move our left index to the right to get a larger value. And we'll see that the left index and the right index are equal to one another, which tells us that the target sum is not in the list, and we should return false. So let's code that out. Okay. All right. The first thing we're going to have to do is get the length of the list. So len of num list, and then we'll set the left index to the minimum, the right index to the maximum, which is the length minus 1. And then let's create a while loop. While the left index is less than the right index. Value equals left index of, excuse me, left index plus the num list plus the right index. Right, and then we're going to have 3 if statements. So we're going to say if the target's equal to the value, we are done and can return true. If the target is less than the value, we're going to want to decrease our value. So that's done by moving our right index to the left by 1, or decrementing it. And if it's greater than the value, we will do the opposite. We will add 1 to the left index. And we're done. We just have to return false. Okay, so the third way to solve this problem, and by far the most efficient, is by utilizing a hash table, or specifically a set. So pretty much what we're going to do is we're going to keep track of every single value we've seen so far as we walk through the list. So let's say we have this num list. Let's put this array of values. Okay, I'll simplify it. Let's say my target's equal to 3. And let us create a set, which is a unordered collection of objects, and we're going to put the numbers that we see as we walk through the list in this set. Okay. So when we start walking through the list, we only have our set is empty, right? So all we're going to want to do is add this current number into our set, right? So already seen will become 34, and then we're going to keep on walking. So then once we get to the second term, we know that in order to hit our target, we need a number equal to -40, right? Because that's the number that's going to give us 3. So we're going to look at already seen, and we're going to ask if we have a -40, and we don't. So we add 43 to our set, and we keep moving. Then we end up at 1, and we know that in order to reach the target, we need the number 2. But we don't have the number 2, so we add 1 to our set and keep moving. Okay, so finally we get to the number 2, and we know that in order to get to 3, we need 1. And it just so happens that we have 1 in our already seen set, so we can return true. So let's see what this looks like. So for number in num list, difference equals target minus num. If difference in already seen, return true. Otherwise, we are just going to add the current number, to our already seen set and keep moving. And then we're done. Okay, so let's just quickly walk through everything we did. Alright, so the first solution we did is in big O order n squared time, and we pretty much just got every possible combination of every two numbers and added them together. And this is clearly inefficient, and we don't want to do this. For the second solution, what we did is we sorted the list and then started at either end, and then kind of moved inwards, right? And the reason that it's L log n log n, is because this sorting operation right here is capped at order n log n, right? So even though this rest of the function is linear, this first part of the function dominates, and the overall order is n log n squared. Okay, now finally for this one, for this last solution, since we're using a hash table, or set, we only have to walk through the list once, and therefore it's order n time, and it is the most efficient of all the solutions. So